Hi, this is Dr. Frederick. We want to do an ANOVA by hand. An ANOVA is a very easy statistical test to complete using the software package. It's not hard to do by hand. You just need to be careful and have some way maybe to take the tedium out of calculations. But here we have 20 participants who, I think what they did was take a memory test using some sort of strategy. And this is the number of words they recalled using a particular strategy. It's something like that. It doesn't matter what it is. What we want to note is that we have 20 participants. We have 4 groups. We have 5 participants in each group. Okay, so our N is 20. And we can go ahead and start looking at our table over here. The degrees of freedoms for the sums of squares total is 20 minus 1, or 19. We have 4 groups, so for our sum of squares groups, we have k minus 1, or 4 groups minus 1, 3 degrees of freedom. And then within each group we have 4 degrees of freedom, 5 minus 1, so a total of 16 for 4 groups. So 3 degrees of freedoms for our 4 groups, 16 degrees of freedom for the 20 participants, and then a total of 19 degrees of freedom. So what we're going to do is calculate the sums of squares. Here they are here. And then we'll take the degrees of freedom, divide it into the sums of squares to get the mean squares. We divide this mean square by the other one to get our F ratio. F stands for Fisher, the guy who invented this test. And then we'll say, if we have an F with 3 and 16 degrees of freedom, the critical value is 3.24, and I'll show you how to do that shortly. Our computed value with 3 and 16 degrees of freedom is 6.02. This is the most extreme value we expect when the null hypothesis is true 95% of the time. Our value is more extreme, so we're going to say there's something about the strategies here that leads one group to have a higher mean than other groups. Not all the means are equal, as it turns out. That's what we learned by doing this test, is that these means are not all equal. And you say, well, they don't look equal. Well, variability happens, so it's more than mere variability that accounts for the differences in these means. It's something to do with these strategies. And we might say, okay, well, rhyming is probably, definitely better than an adjective method, but we still don't know that yet. We'd have to test that with what's called a Post-Hoc Comparison. Okay, so this is the overview, is that we're looking to compute an F-score based on the degrees of freedom. We know what the critical value is. If our value is more extreme than this critical value, then we reject the null hypothesis. The null hypothesis is that all the group means are the same. And the alternate hypothesis is they're not all the same. It's not exactly, we don't have any directional hypothesis with an ANOVA. If we find significance, we'll do post-hoc comparisons, 1 versus 2, 1 versus 3, 1 versus 4, 2 versus 3, 2 versus 4, 3 versus 4. We'll do 6 comparisons. And there's many different ways to do those comparisons. Okay, so let's figure out how to do these sums of squares. And so the first thing we'll do is we'll look at what is the grand mean of all 20 values. Well, it's 12.15. And here we'll take the deviation of each score of the grand mean from each observation. 12 minus 12.15 is negative 0.15. And we'll square all those. We'll do that 20 times. We'll square them all. And that's our total sums of squares. So the total sums of squares is the value of each observation minus the grand mean squared, and then add them all up. That's very, very simple to grasp. Okay, now we'll do what's called sum of square error, in which we will take the value of each individual observation and then we'll subtract the group mean from it. So 12 minus 13.2 is negative 1.2. 13 minus 13.2 is negative 0.2, so on and so forth. Then over here we'll have 16 minus this group mean of 15.2. So we'll do that 20 times, square those, add those up. That's our sum of square error. Now the last one is that we have, let me fix this. We have our group means. We'll find the deviation from the grand mean. We'll square that deviation, multiply it by the number of observations in each groups. We'll take those totals, add them all up to get our sum of square groups. Okay, so you can follow the math on here. And, sometimes we call things different. I don't know why the course developer calls these things groups in error when the book calls them different things, but groups is between, within is error. There's just a lot of different ways to name these things. Sums of square totals never really has another name. Now the last thing I want to do is just show you how to find the critical value. I just don't use tables anymore. The reason I don't use tables anymore is because it's tedious. You can, find your critical value easy with something like this. Well, I haven't used this one. That's not what I was expecting. Let's, here we'll use this Daniel Sloper. That's very easy. Okay, so our degrees of freedom was 3 and 16. So we'll just put 16 in here. Our alpha is 0.05. Calculate. And we'll see that it's 3.24, which is what I had here. Okay, that's how you do these sets of problems. Let me know if you have any questions.